In this video, we are going to discuss a special kind of sequence called an arithmetic sequence. What is an arithmetic sequence? We'll dive in and figure that out, as well as be able to determine something called the common difference. And in the second half of the video, we'll even dive deeper into coming up with formulas that describe arithmetic sequences. Can't wait, let's do it. So this says arithmetic sequences. Determine if each sequence is arithmetic. If so, state the common difference. So what makes a sequence arithmetic is whether or not the sequence increases or decreases by adding the same number to every term to get to the next term in a sequence. So sequences can go increasing, they can rise in value, or they can fall in value. What makes it arithmetic is if the amount is the same that we add on every time. So in this particular sequence, we notice that to get from 9 to 15, we would add 6. And to get from 15 to 21, we add 6 again. And 21 to 27, we add 6. So the sequence is arithmetic because we add the same number to every preceding term to get to every next term. So plus 6 gets us to every later term. So yes, this is arithmetic. And the common difference, I'll just abbreviate that CD, is equal to 6. And that's because that's the difference between every term that is in common. Makes sense that we named it that way. So B, we have 3, then 9, then 27, then 81. Sure, we go up by 6 from 3 to 9, but then we go up by 18, and then we go up by, oh my goodness, 54. So this is not an arithmetic sequence because the numbers do not increase by the same constant added value. And so it is not arithmetic, and so we don't have a common difference. One other thing I'd like to point out is that we could have an arithmetic sequence that goes down in value. So let's start out with something like, I don't know, 20, 15, 10, 5, and then it just keeps on going with that pattern. Here, we're going down by 5 every time. So you can think of that as plus and negative 5 or minus 5 every time, and the common difference would be negative 5, right? So here, common difference would be negative 5 because that's the amount that we go down by each time. On the flip side of the video, we're going to go over how to actually write formulas for these. So I'm going to leave this work up here, and I'll erase this guy, and we'll come up with a formula that will allow us to find any term in this sequence, because there's infinitely many terms in this arithmetic sequence. See you on the other side. And here we are on the flip side of the video, where we are going to go over how to find the formula for any arithmetic sequence. So in the previous half of the video, we found what the common difference was, right? The common amount that we added or subtracted to get to every term, every next term in an arithmetic sequence. And we learned how to identify what an arithmetic sequence is, or when it's an arithmetic sequence. Now we're going to use this formula to come up with a way to generate or make any numbered term in the sequence. So let's say I want the 152nd term of the sequence. Well, we can use this formula to get there. So let's go over what this formula means and why it makes sense, and then we'll use it with each of these problems, and we'll call it a video. So this means the nth term. So that's any term in the sequence. Like it could be a sub 22, which would mean the 22nd term. And that's equal to the first term plus n minus 1, where n is the number of terms that you have, that you've gone out, times the common difference. And this part makes the most sense. Think about it this way. If you have plus 6, then plus 6, and plus 6, and we're getting to, let's say, a sub 4 from a sub 1. If I want the a sub 4th term, I would take the very first term, which in this case is 9, and I would add on 4 minus 1 common differences. Why 4 minus 1? Well, the number of spaces we have between the first and the fourth term is 3. 1, 2, 3, which is the number of times that we're going to be adding the common difference, which in this case is 6. So we're repeatedly adding, or multiplying, 6, 4 minus 1, the number of spaces, times. So in general, you'd have the first term plus n minus 1. That gives you the number of spaces, or the number of times that you're repeatedly adding or multiplying the common difference. And that's why the formula works so well. So we'll see here that we get the fourth term out, which is pretty cool. 9 plus 3 times 6. And that's going to be 9 plus 18, which is 27, which indeed is the fourth term. Nice. So how do we get, let's say, the 51st term? Well, we'd write a sub 51 is equal to, again, we start at 9, plus n is 51. So you have 51 terms we're going out to, but we subtract 1 to figure out the number of spaces in between all the terms. So there's 50 spaces times 6. That's the number we're adding 50 times. That will give us 9 plus 51 minus 1, which is 50 times 6. This is the number of times we're repeatedly adding 6. So this would be 300 plus 9, which is 309. So think of this number or this amount as the amount of change that happens, and we add the amount that's changed or the amount that's earned or lost to the original number, and that gets you to whatever term value you want. So the 51st term is 309. Oh, it's so sweet. All right, we're going to look at this second problem here, and I'm going to do the same thing with the formula just to exercise your abilities. So the formula we're going to use again is the nth term is equal to, and I'm actually going to stretch your mind a little further here. So the nth term, a sub n, is equal to the first term plus n minus 1 times d. So in general, our formula will be that the nth term is going to be equal to 20 plus n minus 1 times a common difference of negative 5. And that's the formula that will generate for us any nth term. So here we could have had a sub n equals 9 plus 6 times n minus 1. So in this case, we could plug in any number term we want. So let's say we want the 20th term. Well, the 20th term would be equal to the first term plus 20 minus 1 times negative 5. So now we multiply everything out, simplify it down, you get 20 plus 19 times a negative 5. Well, that's going to be 20 plus negative 95, or 20 minus 95. And that is negative 75. So the 20th term in this sequence of going down by 5 is negative 75. There you have it, folks. Arithmetic sequences. Go rock some more.